My name is Francesco. All right, it's okay. As the wise man said recently, I'm the most Italian you're gonna meet today. When being Italian, I really like loud places. So just please speak up, talk to me, just don't wait until the end if you have any questions. Also, feel free to interrupt. We Italians interrupt all the time.
Although please use the mic so we can catch it on the video.
Oh yeah, okay, that's fine. It's fine. I work at Samsung. I work on the Xclipse GPU part of that tech. I help developers make games and make fast renders on our GPU, but most GPUs that run on the mobile. In 2019? Yeah, this time I spoke publicly. I'm super excited to speak publicly again. I went to the stage at Google I/O because I was introducing Tom here in Jianghu. Yeah, hey Tom. It was like tough to introduce. And I just went on the stage, it was like, Vulkan is ready for prime time. We're good to go. And of course, I was referring to mobile, which was a bold statement at that time. Now, my face here is not in sync with the mood of the slide. This is a happy slide. I think I'm still today on board with that statement. Vulkan was ready for mobile, for prime time at that time. And I think it's still ready today. It's even more ready. Oh yeah, thank you. Because drivers are way more mature than they were at the time. I'm talking 2017, 2019. There was a time I was working on a game somewhere in the north in Montreal. It was very cold. But the point is, we were trying to optimize this Unity game. We turned on the Vulkan renderer. It was running great, 10 milliseconds per frame. Then on a specific device, we saw 100 milliseconds per frame. And the reason was that the driver was saying, oh, we do support secondary buffer. We're really, really good at that, trust me. But under the hood, it was taking a secondary buffer, just doing a map copy every time it was invoked to the primary buffer, which was slow, to say the least. And there was an example, I'm not going to say who did it, of course, but it was an example of driver's maturity at the time when you were trying to target as many devices as you could. With Vulkan, you were hitting these terrible corner cases, just performance class. It's not as bad as more today. Also, there's more validation as we have learned in the last couple of days, and this helps a lot with writing stable Vulkan code that can reach as many devices as possible, because this is what I want to talk about today with Filip. What he's trying to do, and he took me very seriously when I said that it's ready for prime time. Just create the entire game engine in Vulkan, taking me seriously. I was flattered. Nobody takes me ever seriously, and they did. And trying to reach as many hundreds of millions of people as they are with their platform in Vulkan was a feat. Like, that was hard. In fact, making games on Android is still hard today. Tools are not where they're supposed to be. Now, as I said, I work with the Khronos Group. The Khronos GPU has a very mature support for Vulkan in general. It was the first GPU who supported ray tracing as well. Right? Yep. It's also pretty fast at that. Ads. And that helps the ecosystem moving closer and closer to desktop quality rendering on mobile. And when it comes to this specific concept, like what I wanted to ask him was what helped you recently in the last few years, what in Vulkan to write your render, and then it's surely going to talk more about it. Sure, later.
Yeah. I hold it. Yeah. All right. Cool.
Is this working? Cool.
Yep.
So, I mean, what we did was we built a whole new game engine, creation engine, as we call it, actually. I'm going to go into it a little bit more in detail soon. But what we ran into, since we were using the next generation APIs exclusively, is starting out with Vulkan, we realized that because of the fact that this was entirely super verbose, which was not always a good thing, we were able to actually understand why game engines design their rendering architecture as they did in the past and what can be made better today. So the best thing that we actually encountered, first of all, when we started with Vulkan, was the fact that it was super verbose. It hurt, and it would continue to hurt for quite a while. But the best things that really happened with that is that over time, Vulkan started simplifying. And that's something that we'll talk about more soon as I go into what we're doing. But what we're seeing is Vulkan is becoming less verbose. We're seeing features such as dynamic rendering, uniform buffers, etc., that start making it better. And all this is what's making building game engines easier, and that's what's amazing about Vulkan. Yeah.
Awesome. And yeah, we're working on a new GPU profiler. Look at this introduction. We're working at Samsung with Google. I used to work at Google with Kian over there on AGI. And if you remember, it's almost like every meeting was like, just make it like Pix, make it like Pix. And that's because when I was working in the dark ages on Pix, I worked so much on that specific tool that one of the screens I had was that the UI was built into just basically you could see the UI Pix when you turn the screen off. And that's what we try to do with AGI, making it as much as possible similar to Pix that you could make it on a mobile platform. And the tool that we're working on with Google as Samsung is, we can say, the spiritual successor of AGI. And at some point, I don't know which one. Okay, I have to press the. This is very complicated. Yeah. The GPU profiler is based on Perfetto, same as AGI. It has a system trace at the moment that we are improving on, same as AGI. It works as a plugin architecture, so it's supposed to be working on any mobile GPU as long as someone provides a plugin, I guess. So it's not only for Samsung or Pixel devices, and it's using GFX Reconstruct to record or play vocal calls. And I don't know when it's going to come out at some point. Just get in touch with me afterwards if you're interested. Give it a go when we have a version. Also, since I work in DevTech, and since my job has been for the last 5 years to look at games performance, just if you're making a mobile game, just reach out. I'll help you. It's my team with Patrick. We're going to help you on that. We worked recently with him. And we had a very deep technical collaboration. I wasn't just there to cheer. Well, I did a lot of cheerleading, but that's not. We also wrote some code. And the goal of our collaboration with Sceneri was to try to bridge as much as possible the gap between desktop and mobile. And then we're going to present some use cases, and I'm going to present the use cases that we work specifically.
Interesting.
And that was very good. That will highlight the difference between writing a renderer for mobile and writing a renderer for desktop, specifically when you're focusing on improving performance. It's just a really different beast. And of course, we're going to show you some ray tracing because it's just cool. It's this one. Oh, Filip will go more in depth.
All right, thank you. So, I mean, what Fran mentioned quite a bit, and can everybody hear me all right? All right, cool. So what we've been doing is building a completely new creation engine that is built entirely initially with all the new, I can't even call them next generation graphics APIs anymore. It's more about the new APIs. That one's better? Oh, I see. That's why it was red. All right. So yeah, essentially we're building a new creation engine where you're able to create on any device. And we're really, really excited about this. And we've had to start rewriting the renderer from scratch to handle mobile, creation on mobile, dynamic everywhere. And there's a lot of really unique challenges that went into that. If I continue here, I'm probably going to skip talking too much about our teams, but we come from modding, we really focus a lot on high quality visuals, regardless of devices. And that's what's really special about us. We have written an entirely new renderer that can run and again, create on any device. I can pick up my phone and start creating a game. I can pick up my Vision headset, create a game. I can do it on desktop as well. And there's, like I mentioned, some really, really unique challenges about all that. I realized before I went into this that I created way too many slides for 30-minute talks. I'm probably going to skip over a couple of them. But what we built together with Samsung is a ray tracing demo that runs on the latest Samsung device, where essentially we can do full ray tracing on the latest Samsung chip that runs extremely, extremely well on phone, where not only can you actually view the ray tracing itself, but you can immediately go into a full game editor and start actually modifying the scene on device, which has been really, really interesting for us. And that's what we're really excited about, because of the fact that typically when we develop games, the biggest thing we can do is just say, you know what, we're shipping this to the user. We know what the scene looks like. We know what textures are used, etc. So we can optimize for that. We have to throw all that out of the window because of the fact that the user can decide, where does the barrel go? What kind of asset do they use? What does the scene look like? What is the gameplay? And that means that we have to figure out how to make everything super dynamic. And that's where the next generation graphics APIs really come in. So let's see here. So what really comes into Sceneri itself is that we utilize a job system that, if you guys know about Doom Eternal, we have no main thread. We run everything super asynchronously, and that's where Vulkan really comes in and being super parallel with being able to record across the different threads at any moment and actually be able to get the peak performance from mobile to desktop, regardless of what you're really scaling to. And we're also having one unified renderer where we render the UI, we render the world, 2D, all of this with the same technology. So what I really wanted to talk about here in terms of Vulkan was how doing something fully asynchronous is pretty new. Not a lot of engines do that. Not a lot of creations engines do it. So what we've done is essentially created a system where we create one thread per logical core that you have on device. And each of these things start essentially executing the commands to render a frame, to handle the game logic, to handle all of this. And it's interesting. It's a fun experiment that I'm sure some of you guys have tried to do. And what's important here when we start targeting mobile is you have to think about battery life. You have to think about whether you're running on a performance core or efficiency core. And this is kind of where the rendering itself comes into play. What we've done then, as you can see already in the presentation itself, is have essentially a job manager that contains all the different threads that exist. And we have one thread per logical core, like I mentioned before. And then you have essentially different things that come into play underneath that. In order to be extremely efficient on Vulkan, we have descriptor pools per each one of these job runner threads. We have command pools, and in addition to command pools, in order to actually acquire a new command bucket to render every frame, we have a per frame command pool where you can essentially make sure that you can get a new command buffer extremely quickly, start recording across maybe 64 different cores at the same time. And what you will probably notice if you've ever worked with Metal is that because we started with Vulkan and slowly started improving the API to be simpler and simpler, actually we kind of landed on an API that looks very similar to Metal. And that's probably where we'll go in the future, going simpler and making things more streamlined. And it's also very similar to WebGPU, which is very similar to Metal as well. But yeah, I will probably upload the slides after this for some more information, so I won't go into all of it. But what's important when you're rendering across different threads is that you have descriptor pools for each thread, that you manage the memory that you have. For example, if you have efficiency cores and you have performance cores on heterogeneous architectures, you might want to say that, for example, let's say textures. You don't want as many textures on a high performance score as you do on an efficiency one, because you won't be doing the same operations there. And again, when it comes to per frame command pools, you want to record across any device or any thread. So what you want to do at the end of rendering a frame is actually just called VK reset command pool, and that will make sure that you can completely restore state and next frame very quickly, effortlessly to start rendering again without having to reallocate these command pools and restart. And more than that, we do this all of the engine where we have memory pools per thread. So if you want staging buffer, if you want device memory, you can just do that from scratch.
If you want to be on the video, you should probably stand for that.
Oh yeah.
And that's not working very well. So
You don't worry. I'll just stand here. I'll try to stand still. I'm not good at it though, just like Fran. Yeah. We do a lot of very special things with the job system. For example, we have for each job that we run, which could be a render pass, it could be a compute pass, we allocate a priority. So from 0 to 255, we essentially determine, is this the top priority thing? The top most of priorities would be ending a frame, and the bottom would be the least important thing ever. For example, deallocating some resources that nobody cares about. These things are then split into buckets where we can, for example, say per frame rendering should run on performance cores. Background things, like I just mentioned, should run on the efficiency ones. And all of this becomes very, very interesting in order to be super parallel and be super, super fast. And yeah, we're kind of looking at how to make this faster over time, because debugging this and trying to make a new game engine that is so incredibly parallel that doesn't even have a main thread will probably lead to us trying to figure out how can we handle more than one type of core in a chipset, and actually even on the software side being aware of this so that we can say X job is on the highest clock core, another job that is not as important is on the middle, and the least prioritized jobs such as HTTP would be on efficiency cores. A lot of this really goes into it, and the point is that Vulkan helps here because in the past we never had this control to think about multiple threads, to think about how we can render across here, managing resources, etc. And this is where I see the future in terms of being able to really use the hardware that exists and push forward. And yeah, besides that, we focus a lot on iteration time. And this is where not just Vulkan comes into play, but also things like WebGPU. We use that so that anytime we have a rendering change, we can simply push a pull request to GitHub, and within, say, 5 minutes, we have a completely new web build that we can start up and see the different changes that exist. And this is how we really stay lean and keep producing. The only reason I talk about this is that I'm really excited about this level of iteration of just seeing the changes, instantly previewing, and getting back to coding so we know what's going on. But yeah, what we're really here about is the rendering architecture. And what I'm most passionate about when it comes to Sceneri is our frame graph. What we focus on very, very heavily is ensuring that despite leveraging only the next generation graphics APIs, we make sure to hide things like pipeline barriers, the different managing and loading of resources like textures, buffers, etc. And I mean, this isn't a new concept. Having a frame graph has existed before, but when it comes to everything being super asynchronous, when it comes to having all these threads and loading on a mobile device as quickly as, let's say, people from Generation Z and Generation Alpha that are used to things like TikTok expect, we need to approach things differently. So what we do here is split things into the frame graph itself, and we can actually have multiple frame graphs which are loaded depending on the resource. For example, when you go into the main menu of a game, a frame graph is loaded which only contains essentially 3 different operations: clear, render widgets to a render target, and then copy those to the actual swap chain itself. When we hop into a scene, that gets more complicated. Deferred rendering, SSAO, like all these different things come into play. And again, this is where it becomes similar to essentially what happened with Metal, except on a higher level. So how we've really split this up is you have the frame graph, you have a pass, which might be a compute pass or a render pass. And then immediately after that, it can either be a stage, such as a compute stage, or, and this is how we handle essentially instant rendering, we do off-tree traversal on the GPU using compute that is then directly uploaded to buffers containing instance, transforms, identifiers, etc., that can then populate what we call render item stages. I'll try to go into that into detail later, and there's some notes really here. But what's important about the frame graph is that it optimizes tiled rendering on mobile, it optimizes the desktop, and it allows you to really think about how you do, well, performance rendering, essentially. So you don't have to think about load up, don't care, store up, don't care, etc. You don't want to think about all that. You just want to write graphics, and that's what we do. So we'll automate moving things between queues and so forth as we go along. Yeah. I dropped quite a few details into these slides, and I'll probably upload them afterwards. So you see that the way that we build the frame graph itself is first we describe all the passes and attachments that exist within a frame. And I'll have an example right after this. Afterwards, we temporarily store state information for each attachment that goes into this frame, like let's say UI, HDR scene, the swap chain render output itself. And after that, if an attachment was actually referenced in a prior pass, then that is where we can start inserting dependencies to generate things like pipeline barriers, etc. I won't go too much into all that, but you can see a little bit of an example if you guys are able to see it on the screens right here. And being able to actually define a very, very simple frame graph. And this is kind of where we see things going, and being able to define this for mobile, for desktop, etc. And yeah, build a simpler pipeline where even we as graphics programmers don't have to think about the barriers. We don't have to think about those things despite existing. My own mantra is hiding things even from myself so that I don't see these things. They're just automatic happening behind the scenes. Yeah. Has anyone here built any frame graph of any kind? Yeah? Do you guys have any thoughts or questions based on that? All good if not. Cool. All right. And more than that, what's really important about what we're doing is that we also have a very minimal API wrapper where we try to fit the likes of Vulkan, Metal, Web GPU into the common functionality between all of those APIs. What makes this different compared to having OpenGL, etc., is that we're able to really make a simpler renderer with the latest functionality, not having all the technical debt from before, and really being exclusive to these next generation APIs, such as Vulkan, allows us to be much, much faster, much more versatile in designing our API in general, making this easier to work with. What I even mentioned in the slide is that this is a never-ending journey where what we try to do is always look at the latest functionality. What we started out with Vulkan when it was 1.0, 1.1 was verbose as hell. And the new things that have started happening are timeline semaphores, simplified desynchronization. I would recommend that everyone start using those instead if you haven't already. Uniform buffers instead of having to manage descriptor pools, etc. All this is what really makes it possible to simplify and create different engines. Yeah, and again, being more and more asynchronous is super important. Being parallel, not blocking, all of this is what Vulkan really allows. And over time, I think that what our dream is anyway with a renderer is actually shifting more and more into data so that the creation of pipelines, the creation of stages, all these things don't require you to optimize manually. Instead, if we have something like a frame graph for the whole renderer with buffers, textures, etc., we'd be able to essentially optimize the whole frame, the whole scene, even if a creator comes in and creates a game on the fly on their phone. And yeah, this is more about what a challenge that is and how we need to have different mindsets in order to tackle those kinds of problems. Yeah, I think I'll skip past a bunch of this and give Fran a little option to talk about essentially what we've done with ray tracing. All right.
No, you talk about ray tracing and talk about super resolution.
Yeah, let's start with super resolution.
Yeah, let's start with super resolution. So we wrote some code, and I have 5 minutes to talk about it. And when I say we wrote some code and we grabbed FSR1 from code from AMD, I mean Patrick did it. There, I was cheerleading. So we grabbed the AMD implementation of SR. We ported it to the frame graph, which didn't take long. And then we optimized it for mobile. And we took advantage of the frame graph that for us was just resizing everything, all the passes, relevant passes like deferred, SSAO, and for mapping. And then we applied the FSR shader as the last pass. Now, I'm not going to go into details because I think I have 3 minutes left. What I want to talk about is the fact that after we did a bunch of optimizations, one of the most important was using FP16 instead of FP32, we got some pixels that weren't looking exactly as good as the original implementation of FSR1. And you have 1/6 of a second to tell me which one is which without looking. The time is up. The important thing is that we got a 60% uplift in the frame rate. And if there is one concept that I would like everyone to focus on when it comes to mobile optimization is you can get away with more IQ degradation than you can on desktop because the screen are very small. And because it's more important on mobile to make sure that I can get to the end of my commute with the phone with some battery rather than some pixels not look as good as they should. Battery life is extremely important on mobile because it translates straight into performance KPI, the financial KPIs like day 1, day 7, day 30 retention, which translates into revenue, translates into money, which translates into us paying our mortgages. Want to talk about the future? I want to talk about ray tracing. You have 1 minute or so.
I have 1 minute, and I'll not try to explain ray tracing in a minute. I apologize. What I see as the future, really, with rendering in general, is more and more of things like frame graph, like I mentioned. More will be shifted into things like descriptor buffers and being able to do dynamic rendering, which kind of ties into ray tracing itself. And then using more and more techniques such as ray tracing for global illumination. And all of these things will push us into a territory where we want more to be dynamic, more to be functional on any device. And this is a big problem that we all kind of have to start looking at because the constraints we dealt with before aren't the case anymore. People are on mobile, they are using their vision headsets, and they expect to create and change the worlds as they experience them. And that requires new technology and new approaches. Yeah, I kind of talked a bit much here, but
do we have time to show the demo that you have, the video?
I don't know if we have it on this computer, otherwise I would have.
Okay, okay, but you can go to him later.
Yep.
While you think about your questions, I reiterate the concept that we help people make games on mobile, so reach out. I help on any GPU on Android, not only ours.
All
right. We got.
All right, thanks.
Yep, go for it.
Very handsome there. And we do have time for a couple questions if we have any in the audience.
Oh, you really rushed me out at the end, right?
One of your slides said ray tracing of web GPU.
Sorry?
One of your slides said ray tracing of web GPU.
So it isn't possible right now from what I understand, but it is something we're looking into already. We have the pipeline to do it on Vulkan, and we have the pipeline to do it on Meadow. So the second someone hands me an API I can use, it'll be there by next weekend. So yeah, we're working on it.
Yeah, no, he's incredibly fast at writing code. It's too fast. He's youngsters.
You mentioned about a profiler that you're
Yes.
working on. Can you tell us a little bit more about that? And if
No.
we can probably
I cannot tell you more about that.
any access, any early access.
You come to me. give me your email. Like, reach me. Sorry, I'll try not to joke about it. Reach me in. Send me a message on LinkedIn. I'll keep a list of people, and when we have a build that we can share, it's like my skip manager is behind you, and there's always a bunch of things I can say, and then I will plug you in. Yep.
In your job system, do you use coroutines also?
We've started integrating coroutines as it is right now, but initially it was not using those at all. But I would imagine that we'll have more and more of coroutines taking over the system entirely as we go along.
Thanks.
Yeah, good time for one more.
You had a slide up there with Molten VK in that you may have run into limitations. I didn't know like what limitations you ran into with that.
To be honest, Molten VK was straight up awesome. Like everyone that worked on that, I love you. You saved a lot of my time. The biggest limitations are really when we started looking into Vision OS. And that was, to be fair, before it came out. There were some inabilities to actually project something in immersive reality to the device, which is understandable. If you're going that far, honestly, I would argue that you should probably be using Metal anyway. So no, usually the Molten VK guys are on top of the game. When there's a new extension that's relevant to people on mobile, they have it. So I would recommend using it if you need it.